Hello everybody. Today we're going to learn how to solve quadratic equations by factoring. To solve quadratic equations by factoring, we will use the principle of zero products. So the principle of zero products states, for any rational numbers a and b, if a times b equals 0, then either a was 0 or b was 0. And if either a or b is 0, then the product of a times b is also 0. All this is saying is something you already know. If you have two numbers and one of them is 0 and you multiply them together, the product will be 0. So for example, 5 times 0 is 0. 0 times 20 is 0. Negative 1,000,000 times 0 is 0. So if you have two expressions and you multiply them together and you get 0, then the product will be 0. And it's important because we're going to be using that today to solve quadratic equations. So we look at example 1. I have x minus 1 times x plus 3 equals 0. So I have two expressions being multiplied together that equals 0. Well, that means, by the principle of zero products, that either x minus 1 equals 0 or x plus 3 equals 0. Because here I have x minus 1 times x plus 3 equals 0. So one of those two expressions needs to equal 0. Well, now I can just solve these two equations. Well, to undo subtraction, I'll do addition and add 1 to both sides and get x equals 1. For the other equation, to undo addition, I'll do subtraction and get x equals negative 3. Both of these are my solution, x equals 1 and x equals negative 3. Both of these solutions are going to work, and I'm going to show you why. Oops, let's do this. All right, so to see if these work, what I'm going to do is I'm going to plug into the equation for when x equals 1. So every time I see an x in this equation, I'm going to replace it with 1. So I'll have 1 minus 1 times 1 plus 3 equals 0. Oops, sorry about that. 1 minus 1 is 0. 1 plus 3 is 4. 0 times 4 is 0. 0 equals 0 is a true statement. So 1 is a solution. Now I can try when x equals negative 3. I'm going to do the same thing, and I'm going to plug into the original equation for when x is negative 3. So I'll have negative 3 minus 1 times negative 3 plus 3 equals 0. Well, negative 3 minus 1 is negative 4, and negative 3 plus 3 is 0. Negative 4 times 0 is 0. 0 equals 0, that works. So that is why we have two solutions, both 1 and negative 3. So let's look over here to the right. It says reflect. This is the graph of y equals x minus 1 times x plus 3. How do the solutions from example 1 relate to this graph? So when I look at this graph, remember that this is your x-axis and this is your y-axis. And we have this U shape. This U shape is called a parabola. And that is the shape that quadratic equations make. When you look at this parabola, what I notice that is the same is that my x-intercepts are where x equals 1 and when x equals negative 3. And those are the answers that I got for example 1. And so when we think about how this graph relates to the problem, the answers or the solutions are the x-intercepts. So every time you're solving a quadratic equation, you're finding the x-intercepts. Let's try example 2. It says solve 7x times x minus 4 equals 0. So I have two expressions being multiplied together, 7x and x minus 4. When I multiply these two expressions together, I get 0. And so because I get 0 as the product, that means that I can use the principle of zero products. So either 7x equals 0 or x minus 4 equals 0. And now I can just solve each of these equations. To undo multiplication, I'll do division and get x equals 0. And to undo subtraction, I'll do addition and get x equals 4. So my solutions are x equals 0 and x equals 4. What I want you to do is go ahead and pause this video and complete this try this problem. Actually pause it and see how far you can get. Don't just wait for me to do it. See if you can apply what you have learned so far. Alright, so I have x minus 3 times 2x plus 1 equals 0. Now it must equal 0 to be able to use the principle of zero products. So because it does equal 0, and I have two expressions being multiplied together, I can go ahead and use the principle of zero products and say x minus 3 equals 0 or 2x plus 1 equals 0. And now I'm going to solve each of these equations. To undo subtraction, I'll do addition and get x equals 3. Oops, sorry. And over here to undo addition, I'll do subtraction and get 2x equals negative 1. To undo multiplication, I'll do division and get x equals negative 1/2. So my solutions are x equals 3 and x equals negative 1/2. So on this first page, all three of these examples were already factored for us. When we look at the next page, you will notice that these examples still need to be factored. So let's look at some of the rules, or the steps. So step 1 is one side of the equation must equal 0, because that's the only way that we can use the principle of zero products. Step 2 is going to be to factor the quadratic expression. Step 3 is to use the principle of zero products to set each factor equal to 0. And step 4 is to solve each equation. So let's try example 3. It says solve by factoring. X squared minus 8x plus 16 equals 0. It equals 0, so that's good. Your first step whenever you're factoring is to always look for greatest common factor. And in this case, I do not have one. When I do not have the greatest common factor, I'm going to go straight to the area model. In your area model, your first term goes in your first box, and your last term goes in your last box. You always want to multiply your first number by your last number, a times c. Because remember, these are all of the form ax squared plus bx plus c equals 0. So my first number is 1, because that's the coefficient of x squared. And I'm going to multiply that by my c, which is 16. 1 times 16 is 16. So that means I'm looking for factors of 16 that add to my middle term of negative 8. And those two factors are negative 4 and negative 4. Negative 4 times negative 4 is positive 16, and negative 4 plus negative 4 is negative 8. These are the numbers that go in the empty spaces of the area model. Now, to complete the area model, we find the GCF of each row and of each column. The greatest common factor between x squared and negative 4x is x. The greatest common factor between negative 4x and 16 is negative 4. The greatest common factor between x squared and negative 4x is x. And the greatest common factor between negative 4x and 16 is negative 4. Now remember, the wonderful thing about using the area model is that you can always go ahead and double check your work. X times x is x squared. X times negative 4 is negative 4x. Negative 4 times x is negative 4x. And negative 4 times negative 4 is positive 16. So what we have just done is that we have just factored the left side of the equation. And that left side of the equation has become x minus 4 times x minus 4. And this is still going to equal 0. Just like how it did over here. So now this looks like the 3 examples that we did on the front page, where I have 2 factors being multiplied together to equal 0. So now I can use the principle of zero products. Both of these factors are the same. When both of your factors are the same, you only need to solve the equation once. So if I have x minus 4 equals 0, and I want to solve this, I'm going to go ahead and add 4 to both sides and get x equals 4. So in this problem, I only have one answer, x equals 4. And so what that means is that if we were to graph this problem, that I would only have one x-intercept. And that x-intercept would be where x equals 4. Let's try example 4. It says solve by factoring. Well, remember, to use the principle of zero products, it must equal 0. Since this one does not equal 0, I need to move this negative 6 to the left side. Well, to undo subtraction, we do addition. So I'm going to add 6 to both sides and get x squared plus 5x plus 6 is equal to 0. Now that it equals 0 on one side, I can factor this expression. Remember that 6 did not have a like term with 5x and x squared. That's why I just wrote it in standard form. My next step with factoring is to always look for a greatest common factor, and here there is none. So when there is not a greatest common factor, I go straight to the area model. My first term goes in the first box, and my last term goes in the last box. You always need to multiply A times C, your first number by your last number. 1 times 6 is 6. So I'm looking for factors of 6 that add to my middle number of 5. And those two factors are 2 and 3. 2 times 3 is 6, and 2 plus 3 is 5. Order does not matter when you plug into the area model. So if you switch 2x and 3x, that is okay. We will get the same factors in the end. Now I'm looking for the greatest common factor of each row and of each column. The greatest common factor between x squared and 2x is x. The greatest common factor between 3x and 6 is 3. The greatest common factor between x squared and 3x is x. And the greatest common factor between 2x and 6 is 2. So what we have just done is we have just factored this left side of the equation. And those factors are now x plus 3 times x plus 2. The right side of the equation still equals 0, so that just comes down. Now that I have factored, I can use the principle of zero products. Either x plus 3 equals 0 or x plus 2 equals 0. And now I can just solve each of these equations. To undo addition, I'll do subtraction and get x equals negative 3. To undo addition, I'll do subtraction and get x equals negative 2. So my solutions are x equals negative 3 and x equals negative 2. On example 5, it says solve by factoring. So remember, your first step is to check to make sure that this equals 0, and it does. So now I'm going to look for greatest common factor. There isn't one. So I'm going to go ahead and go to the area model. My first term goes in the first box, and my last term goes in the last box. You always need to multiply A times C. That gives me negative 36. So that means I'm looking for factors of negative 36 that add to 0. This adds to 0 because if I look back up here, I know that I have my ax squared term, and I know that I have my c term. What's missing is this bx term. And the only way that bx can be missing is if it's 0. And so that is how I know that b is 0, because I do not have just an x term by itself. And so two numbers that multiply to negative 36 and add to 0 are negative 6 and 6. Negative 6 times 6 is negative 36, and negative 6 plus 6 is 0. So these are the numbers that I'm going to put inside of my area model. The greatest common factor between 9x squared and negative 6x is 3x. The greatest common factor between 6x and negative 4 is 2. The greatest common factor between 9x squared and 6x is 3x. And the greatest common factor between negative 6x and negative 4 is negative 2. So we've just factored this left-hand side, and it has become 3x plus 2 times 3x minus 2, and it still equals 0. If you remember that, or if you recognize that 9x squared minus 4 is a difference of 2 squares, you would have been able to jump straight to this answer. If you didn't recognize that 9x squared minus 4 was a difference of 2 squares, then you could have just done the area model and you get the same answer in the end. So it's really your preference and up to you. Now that I have factored, I can use the principle of zero products. Either 3x plus 2 will equal 0, or 3x minus 2 will equal 0. To undo addition, I'll do subtraction and get 3x equals negative 2. To undo multiplication, I'll do division and get x equals negative 2/3. For the other equation, to undo subtraction, I'll do addition and add 2 to both sides and get 3x equals 2. To undo multiplication, I'll do division and get x equals positive 2/3. So my solutions are negative 2/3 and positive 2/3. On this next one, it says try this. And we have 24x squared minus 4 equals 10x. I'm going to help you get started on this. Remember that to be able to use the principle of zero products, one side must equal 0. And right now, one side doesn't. So what I'm going to do is I'm going to subtract 10x on both sides. When I do that, I see that negative 10x doesn't have any like terms. So I'm just going to write this quadratic trinomial in standard form. Now you can factor. So go ahead, pause this video, take a second to factor this trinomial. Alright, so your first step with factoring is to always look for greatest common factor. Here, I do have a greatest common factor. It's 2. So I'm going to go ahead and factor that out. And I'm actually going to do that over here. So I'll have 2 times x, or 12x squared, minus 5x, minus 2. And so now we want to make sure that we factor completely. So now I need to factor inside of here. So to do that, I'm going to use the area model. 12x squared goes in the first box, negative 2 goes in the last box. I always need to multiply my first number by my last number. And when I do that, I get negative 24. So I'm looking for factors of negative 24 that add to negative 5. And those two numbers are negative 8 and positive 3. Negative 8 times 3 is negative 24. Negative 8 plus 3 is negative 5. So those are going to be the numbers that I put into my area model. Now I'm looking for the greatest common factor between each row and each column. The greatest common factor of this this top row is 4x. The greatest common factor between 3x and negative 2 is 1. The greatest common factor between 12x squared and 3x is 3x. And the greatest common factor between negative 8x and negative 2 is negative 2. So my factors are the 2 from my GCF, 4x plus 1, and 3x minus 2. Now that I have factored, I can use the principle of zero products. Here I have 3 factors, 2, 4x plus 1, and 3x minus 2, and when I multiply those 3 things together, I get 0. So one of those 3 factors needs to be 0 in order for this to equal 0. So let's look at all 3 equations that I've written here. This first equation, 2 equals 0. Is that a true statement? Does the number 2 equal 0? No, that's a false statement. And because it's a false statement, we can ignore it and it goes away. Over here, I forgot my equals 0. On this next equation, I can solve this. So to undo addition, I'll do subtraction and get 4x equals negative 1. To undo multiplication, I'll do division and get x equals negative 1/4. For this next equation, to undo subtraction, I'll do addition and get 3x equals 2. To undo multiplication, I'll do division and get x equals 2/3. So in this case, my solutions are negative 1/4 and positive 2/3. Let's look at example 6. It says solve by factoring. So our first step when we're solving by factoring is to look for a greatest common factor. Here I can see that my greatest common factor is x. So I'm going to go ahead and factor that out. When I do that, I'll have x times 5x minus 6 equals 0. This is now factored completely. I know this because both of my factors, x and 5x minus 6, are linear. Remember, linear means that your highest degree is 1. So because each of these factors are linear, I know that I have factored completely. So I can use the principle of zero products. Either x equals 0 or 5x minus 6 equals 0. On this first equation, x equals 0, this is already solved for. X is already by itself. So one of my solutions is 0. For my other equation, to undo subtraction, I'll do addition and add 6 to both sides. To undo multiplication, I'll do division and get x equals 6/5. So here my solutions are 0 and 6/5. On number 7, we have a word problem. So let's see what's happening in this situation. The width of a rectangle. As soon as I read that, I'm going to go ahead and draw a rectangle. The width of a rectangle is 5 meters less than the length. I don't know what the length is, so I'm going to call the length x. If the width is 5 meters less than the length, then I need to subtract 5 from the length. So that will be x minus 5. The area of the rectangle is 24 square meters. Well, I know that area is length times width. Then it says, what are the dimensions of the rectangle? All right, so here is my diagram. Let's see if we can figure this out. I know that area is length times width. So that's going to be x times x minus 5. And they tell me that the area is 24 meters squared. Well, to be able to solve this, I'm going to have to go ahead and distribute this x. And when I do that, I have x squared minus 5x equals 24. I know that in order to be able to use the principle of zero products, that this must equal 0. So I need to subtract 24 on both sides. And when I do that, I get x squared minus 5x minus 24 equals 0. From here, I can factor. There is no GCF, so I'm going to go straight to the area model. First term goes in the first box, last term goes in the last box. You always need to multiply your first number by your last number. 1 times negative 24 is negative 24. So I'm looking for factors of negative 24 that add to my middle number of negative 5. And those two numbers are negative 8 and 3. Now I can find the GCF of each row and of each column. The greatest common factor between x squared and negative 8x is x. The greatest common factor between 3x and negative 24 is 3. The greatest common factor between x squared and 3x is x. And the greatest common factor between negative 8x and negative 24 is negative 8. So we have just factored this left side of the equation. And when we did that, we got x plus 3 times x minus 8. So now I can use the principle of zero products. Say either x plus 3 equals 0 or x minus 8 equals 0. And let's go ahead and solve each one of these equations. To undo addition, I'll do subtraction and get x equals negative 3. To undo subtraction, I'll do addition and get x equals 8. In these types of word problems, it's going to require you to use your brain a little bit. And you have to think about what is reasonable. If I have x equals -3, what does that mean? Well, that means that the length is -3 meters. Does that make sense? No. You cannot have negative length. And because you cannot have negative length, meaning you can't go to a carpenter and say, hey, can you make me a table that is -3 meters long? They're going to look at you like you're crazy. So because you can't have negative length, x minus 3 is not a viable solution. But x equals 8 is, because I can have a table that is 8 meters long. So x is going to equal 8. So I know the length is 8 meters. Let's figure out the width. Well, the width will be 8 minus 5, which is 3. So I know they wanted to know what are the dimensions of the rectangle. The dimensions are that the length is 8 meters and the width is 3 meters. This is your solution. Let's look at this last example. The square of a number minus twice the number is 48. What is the number? Well, I'm not sure what the number is, so I'm going to call the number x. So if I have the square of a number, well, that means that I have x squared minus twice the number. Well, the number is x, so twice x means 2 times x. So 2x means equals 48. Well, to be able to solve this by factoring, I know that this must equal 0. And so in order to do that, I'm going to go ahead and subtract 48 from both sides. And so I'll have x squared minus 2x minus 48 equals 0. So now I can go ahead and factor this equation. There is no GCF. So I can go straight to the area model. My first term goes in the first box, and my last term goes in the last box. You always want to multiply your first number by your last number. 1 times -48 is -48. So I'm looking for factors of -48 that add to my middle number of -2. And those two numbers are 6 and -8. So now I can find the GCF of each row and of each column. The GCF of this top row is x. The greatest common factor of this bottom row is -8. The greatest common factor of the left side is x, and the greatest common factor of the right side is 6. So my factors are x minus 8 and x plus 6 equals 0. Now I can use the principle of zero products. Either x minus 8 equals 0 or x plus 6 equals 0. And I can solve each of these equations. To undo subtraction, I'll do addition and get x equals 8. To undo subtraction, or to undo addition, I'll do subtraction and I'll get x equals -6. Well, let's check to see if both of these numbers work. The square of 8 is 64. Minus 2 times 8 is 16. 64 minus 16 is 48. X equals 8 works. Let's try negative 6. The square of negative 6 is positive 36. Minus 2 times negative 6 is negative 12. So 36 minus negative 12 is 48. Both of these work. So the numbers are 8 and negative 6.